Good evening. My name is Dr. Emmanuel Moya, and I'm the inventor of the alternative power generator. We call it the magnetic power generator, as you could see. And this technology actually originated from Germany and the USA, where the original research was done, and it was perfected and assembled in Canada. So you have 3 countries where this technology originated. Because of the United Nations request for a company or individual to produce power in the remote areas, especially for disaster relief and recovery. So this actually came from that idea. So I started putting my resources and then started the construction of the device until this day that we were able to perfect. So this device actually can power in remote areas, for example, in beaches or in the mountains and so on. And also it can power cooking machine, heating, welding, grinding, and so on. So this is self-generating power. Now, the intelligence of the system is controlled and monitored by the inverter. So we have a monitor that tells you how much charge the battery is, and if the battery is being charged by the system itself. It tells you also the voltage that it is generating, and it tells you how many hours the unit is running. And in this system alone, it will tell you a default or alarm. So if you are low in battery, it will send you an alarm at least a few minutes before your battery is totally drained. And it tells you as well if there is another default or alarm. This actually monitors the operation of the system. Tells you about the status of the battery, if it's charged or charging, the voltage you are utilizing, the number of hours it runs. And then when you have a load, you will see how much load are you accepting on the system. And later on, we're going to put some loads on it. Continuing the process, the variable frequency drive is connected to the drive motor, and this produces a harmonic motion that will start from 0 RPM to the desired speed up to the 60 Hertz cycles. What it does is it allows the drive motor to start slowly until it reaches the peak speed of 1800 RPM. So you have a smooth operation, not a huge startup current. So it's a zero current. And this is actually one of the secrets of the operation. You are not starting at a high current, you are starting at zero current. This is what we call the load center. It generates 220 volts and 440 volts at 3 phase. Depending on the size of the unit, it can go as high as 1. Normally 100 amps to 200 amps. On this side of the panel is actually a solar controller. What it does, because you will have an option to charge your battery using solar panels. In our case, 1 solar panel is able to charge the battery, but you need at least 6 full hours to charge the battery. So if you have 2, 3 hours. So this is a good idea because you have an option on how to charge your battery. If you just run out of power by the battery, so this is another option for you to charge the battery. At this moment, we don't have solar because we're just running with 2 batteries. This side of the panel has an opening which is an access to a 440 volts. So you have industrial type 440 volts 3-phase being generated by an axial magternator, which is a magnetic alternator. So it is another flywheel that assists in the rotation of the magnetic generator. So it gives you more power. The back end side of the generator is what we call a dump load. When the system is not being used, because we're not connected to the grid, we don't have the ability to send the excess power to the grid, we have a dump load. So when the unit is running and there's no load on being used, all the power generated is sent to the dump load, which is actually heat to dissipate the power that it's generated if it's not used. The second unit here is a wind controller. So we have an option as well to provide a small wind turbine, say about 5 kilowatts generator, that can be connected to our wind controller. The output of this again is sent to our inverter that controls the total output. So again, it's an option available to whoever buys this. So the unit has a built-in battery charger, redundant from the battery charger controller that is also in the inverter panel. So you have a second battery charger that charges your battery automatically. So when the battery goes down below 80, it will start doing a trickle charge until the battery goes back again to 100%. The outlets here are 110 volts at the lower end, and the higher one is 220 volts. So you have dual outlets, 110, 220. Now we are on the left side of the cabinet, and I'm showing you the load center for the 110, 220 volts, which is mainly residential. And this is single phase, 60 hertz as well. So the right panel, the right breakers actually are 220 volts, and the left one is 110 volts. So your charger is at 110 volts. Your variable frequency drive on that side is 220 volts. So all these breakers are 220 volts. You can connect anything you want as long as they are 220, or here is for 110. So this unit is actually international use. You have 110 volts, you have 220, you have 400 and 440 volts. Okay, so this is designed for international use. This is the heart of the unit. We call it a permanent magnet generator. So this is a standard alternator, we call it. But in our case, this is modified, and we supply a flywheel in the front. We call it a magnetic flywheel in the front and in the back. The magnetic flywheel consists of an array of magnets, and positioned by North Pole to North Pole. And it is actually induced by 8 solenoid coils. So the moment these 2 poles reach the 1 pole of the solenoid coil, it induces a current. And the current is sufficient to move the magnet by the push, because North Pole to North Pole, they actually push, they don't attract. So when they push, it generates that rotating motion, and it generates the torque. That's why we call it a floating shaft and a floating rotor. So we are going to start the system by turning on the switch here. So you have a power right now. Now the moment you have a green, that means the unit is activated. Now it's loading and tells you what is the voltage available to you. So the moment you start it, it will give you the voltage that's available right now. So right now you have 120 volts and you have 0 amps because you're not using the system. Okay, when we add loads, the amps actually went up. So that is it signifies that you're adding load up to the maximum whatever load you can have. Now the first is the air conditioning unit that exhibited a 12 amps load on a 220 volts line, and then we added the heater and it went up to about 14. Then we add another load, it went on average of 19 for the whole. When you meet the right temperature, the compressor actually stops and so on. But the heating is constant. That's why you have a constant temperature or amp going up. And then the fan is also constant. That's why you have a constant 19.9 amps. The total for these three is 19.9 amps. So the unit can handle up to 60 amps. So in conclusion, we came up with a device, a magnetic power generator that can generate power with multiple outputs from 110 volts, 220 volts, 440 volts, or 600 volts using the same unit. This has the ability to be used all over the world, whether you are in 50 hertz or 60 hertz. For disaster relief operations, remote areas, off-grid, on-grid, you have a unit. Thank you.